welcome back. We're going to talk about chemical bonds and reactions in this second video for Chemistry Week 3. Just a reminder about our last video, what we talked about. We talked about molecules and compounds and mixtures. And here is the yummiest kind of mixture you could ever imagine. This is a mixture of all different kinds of solids. Okay, so we're going to talk about chemical bonds and reactions now. When two or more atoms join together to form a molecule or a compound, they stick together by a chemical bond. And a chemical bond is a strong force that holds them together. Here we have an example of a molecule. And this molecule, all these different atoms are held together by some form of a chemical bond. And we will learn that there are several of those. Electrons from the atom is attracted, from one atom is attracted to the protons in another atom, and this electrical force creates a bond like magnets that are attracting and sticking together. So the types of chemical bonds are ionic, covalent, and there's two types of covalent bonds. There's the non-polar covalent, and there's the polar covalent. And then we have hydrogen bonds and metallic bonds. So the first type of bond that we're going to talk about is called an ionic bond. And this happens when one or more electron is transferred from one atom to another atom. So it happens, it forms between metals and non-metals. And here we have, again, Na and sodium and chlorine atoms right here, and they want to form an ionic bond with each other. So again, if you look at the shells of the atoms, chlorine has an almost full valence shell. It just needs one more electron to become really, really stable. And sodium, on the other hand, because it's a metal and it's on that left-hand side of the periodic table, it has only one electron in its outer shell, its valence shell. And so, man, it really wants to get rid of that electron because it's making it really unstable. So what happens in this ionic bonding, in this reaction between them, is that the sodium is actually going to give its outer electron to the chloride atom, and both of them will become more stable. And they'll both actually become charged. Sodium will have a positive charge, and chloride will have a negative charge. So this type of bonding isn't the strongest type of bond, but it is one of the kinds of bonds that happens between a non-metal and a metal. So sodium, again, has the 11 protons. So therefore, it has that one electron in the outer shell far away from its nucleus, and it wants to give it away. It is easily attracted to the protons in the nucleus of the chlorine. The chlorine with the 7 electrons in the outer shell would love another electron to balance it out and to make it more stable. So what happens is both the sodium and the chlorine become ions. Chlorine now has 8 electrons, and the sodium also has 8 electrons in its outer shell, making it much more stable. When NaCl or sodium chloride dissolves in water, the sodium and the chloride remain, they dissolve in the water and they remain charged in water. And in solution or in the water, it means that they become what we know as electrolytes. So in solution, ions are called electrolytes. Okay, we're going to talk about the next type of bond, and this is called the covalent bond. Most molecules are held together by covalent bonds. A covalent bond happens when two atoms share electrons in non-metal atoms. Ionic bonds involve transferring or giving away electrons, but in covalent bonds, they are actually going to share the electrons. And covalent bonds they happen mostly in organic compounds. So our bodies are full of covalent bonds. Covalent bonds, again, so they're going to share the electron. So here we have an example of chlorine. We just looked at chlorine. And if you'll notice in these atoms, they've only drawn the outer shell. They just went ahead and left the other shells out just to make it more simple. So the chlorine we talked about, it needs one more electron to have that full outer shell. And to achieve this, it can share an electron with another chlorine atom, and this creates a single bond. So if you can see here, the two atoms have come together and they're kind of overlapping each other. And so one atom is represented with the stars, one is represented with the circles or the dots, and now they're each sharing that outer electron. This type of bond is very stabilizing and it's very strong. It's stronger than the ionic bond. So both the hydrogen and the chlorine atoms will form what we call non-polar covalent bonds. The electrons will be shared equally. In this slide here, we have what's known as a polar covalent bond. In a polar covalent bond, the electrons are shared unequally, creating a charge to the compound or molecule that is formed. So we'll have a positive end and a negative end. So as the hydrogen atoms come together and are attracted to the oxygen atom, we're going to have an unequal sharing of electrons, so that where the hydrogens are, there's actually a weak positive charge. And on the other end, where the oxygen atom is, we actually have a bit of a negative charge. And this is what gives water what we call polarity. The polarity of water explains why some substances, like table salt, dissolve in water and others don't, because the salt is pulled apart by the water, by this charge that exists in the water. Water molecules are attracted to each other due to their polarity, forming a type of loose hydrogen bonded lattice work. And this bond is about half the strength of a covalent bond. So hydrogen bonds can occur with other electronegative atoms, such as fluorine, oxygen, and nitrogen. Here's a picture of what water looks like on the molecular level. And so you can see here between these two molecules of water that because of the polarity, that the hydrogen atoms have a positive charge and the oxygen has a negative charge to it, those two ends are attracted to each other. And so that's happening all throughout water, and it's making it stick together. So chemical reactions result from chemical bonds forming, and also in bonds being broken and new ones forming. And that brings us to what we call the reactions. The event of atoms or elements or coming together to form this bond is called a chemical reaction. In every reaction, there are reactants and there are products. And what remains after the reaction is the products, what happens before the chemical reaction, those are the reactants. So those are the compounds that are reacting together. And this chemical reaction can be shown by an equation. And here we have the metallic bonding, which I forgot to talk about. And the metallic bonding, just to go back, is showing how metal atoms are overlapping, and all those valence electrons, they're kind of just being shared. And it actually is what gives metals their physical properties of being malleable and ductile and a good conductor of heat and electrons, because they it's just an overlapping and sharing of those electrons, and it gives metals their distinct properties. So here we go. Here we have our chemical reactions. We have our reactants, the C and the O2, and they react together to form the new product, which is CO2. So a chemical reaction is a change that takes place when one or more substances, called reactants, form one or more new substances called products. And there are 4 main types of reactions. Here we have the 4 main types of chemical reactions. We have the synthesis, where we have 2 reactants that come together to form one new product. Then we have decomposition, which is basically the opposite. We have one reactant, and what happens is it decomposes into 2 new products. So product A and product B. Then we have what's called a single replacement. We have the reactant AB reacting to C to form AC and B. So there's a replacement that's happening. And then we have the double replacement, where you have product AB reacting to CD, and then they're actually swapping. So you end up with AC and BD. So you have the 4 different types of reactions there. Reactions can be very violent and explosive, such as when sodium and chlorine combine to form table salt. And there's a lot of heat that is produced as well. So when you have the combining of sodium, so you have let's say you had 2 atoms of sodium combining with Cl2, which we saw is 2 covalently bonded Cl or chlorine atoms. They come together explosively and create 2 atoms of sodium chloride and heat. And heat is also a product of that reaction. And this is what we call an exothermic reaction, because it gives off energy. Energy is one of the products. The opposite of that would be an endothermic reaction. An endothermic reaction needs energy to actually happen. We learned about photosynthesis and cellular respiration in our ecology unit. And photosynthesis is when carbon dioxide and water combine, and with the help of solar energy, they form glucose and oxygen. And that's all taking place in the plants. So the opposite reaction is cellular respiration, where you have oxygen and glucose coming together and producing water and carbon dioxide and giving off a chemical energy, ATP, which is used in our body. It's a type of energy that our body uses in metabolism, and heat as well. So there's an example. These are examples of endothermic and exothermic reactions. And that is the end of video 2.